Good morning, students. Today we will start a new topic from the chapter machines, that is called the pulley. Previously, you have studied some other simple machines like the basic definitions of what is MA, that is mechanical advantage, what is velocity ratio, that is VR, and what is the meaning of efficiency. Now, continuing with the topic, we will study and we will learn what is a pulley. Basically, a pulley is defined as a disc which can be of metal or wood, and along the groove, there is a groove along the circumference, and along that there will be a rope which will be passing, and you can hang a load on one side of the rope, and you can apply a force on the other side of the rope in order to lift the load up or down. Let's see how it looks like. So this is one fixed support from where you are hanging this disc, which is the pulley, and along the circumference there is a groove and a rope passes over it. One side of the rope is carrying a load, which is, we can write as L. L is the load here, and on the other side you are applying a force in the downward direction, and this force which you are applying on the downward direction will be lifting this load in the upward direction. Or in other words, we can say that if you pull this rope downwards, let's say by 1 centimeter, then on the other side this load will also go up by 1 centimeter. Of course, here we are assuming a few things. First thing that we are assuming is there is no friction between the rope and this pulley. And number two, we are also assuming that this rope, which is extending like this rope is inelastic in nature. That means it will not expand or contract depending on the weight. So these are the two assumptions we are making. Now what happens? This load will be acting in the downward direction. We know that the load is because of the weight of this substance, this box or a blank. Now this load will be acting in the downward direction. According to Newton's third law, we know that every force has an equal and opposite, every action has an equal and opposite reaction. So there will be a reaction force acting along the rope in the upward direction, and this reaction force is called T. T stands for tension. So this is the tension. Similarly, this effort is acting in the downward direction. Therefore, there will be an equal and opposite tension force which will be acting in the upward direction. Now, from this, what you can make out, if you look at this side, when this load is neither moving up nor going down, that is at equilibrium, we can say that this T is equal to E, and from this side also we can say that T is equal to L, which is the load. Now, if we compare these two lines, what do you get? We get L is equal to E. That means load and effort, they are similar. Now we know from the definition of mechanical advantage, MA, that is the mechanical advantage, is equal to load upon effort. Now since load and effort they are equal, therefore we can say that MA, that is mechanical advantage, is equal to 1. Okay. Now let's find out what will be the velocity ratio. I wanted to recall the definition of velocity ratio, which you have already done in the previous unit. Now, velocity ratio is defined as the ratio of the displacement due to the effort upon the displacement due to the load. Now, what is the displacement due to the effort? You can write it as dE, and the displacement due to the load we can write it as dL. Okay. Now, this dE and dL, like I told you at the beginning of the video, that dE is nothing but displacement of the effort, how much you have pulled it down. Suppose you have pulled it down by 1 centimeter, then the load will also go up by 1 centimeter. So dE and dL, these two will be similar, equal to each other. We can say that this is also D, this is also D, and your velocity ratio becomes 1. Now let's recall what is the definition of efficiency. Efficiency is given by the symbol eta. Now you know that efficiency is nothing but MA upon VR. Now since MA, that is mechanical advantage, is 1, and here that is velocity ratio is also 1. Therefore we can say that the efficiency eta is also equal to 1. In other words, we can say that the efficiency is 100%. In real world, you can never find a machine which has got 100% efficiency, but here, if you remember, the assumptions that you have made are the rope is totally completely frictionless. There is no friction between the rope and the pulley, and of course this rope is inextensible, that is, it is not elastic, it will not expand or contract. So this is all about pulley, and this type of pulley is called a simple fixed pulley. So that's the end of this short video on pulleys. I'll come up with more such videos. Till then, goodbye, and once again, please subscribe to my channel, because once you subscribe you will get notified of the more videos that are coming up. Till then, goodbye.